black holes are no longer science fiction. They're science fact. Scientists agree these whirling vortexes are born out of the death throes of massive stars. When a sufficiently massive star runs out of fuel, it is unable to support itself against its own gravitational pull. It then collapses inward to form a black hole.
Black holes are troublemakers in the evolution of the universe. They can draw matter in, spew it out, reform, reorganize regions of the universe, perhaps part of a galaxy, take up residence at the center, start running the show. They're big muscular things that lumber around and cannot be stopped.
Black holes are difficult to detect because they're black. But they can be observed when they interact with something in space, such as in falling gas, which heats up and glows in X-rays.
Years ago, black holes were considered to be impossible. We have something called the giggle factor in physics. People used to giggle whenever we talked about black holes. But now, we see hundreds, thousands of glorious photographs of black holes.
There are at least two types of black holes. One is called a stellar mass black hole, which is approximately 3 to 30 times the mass of our Sun. It's speculated that 100 million of these reside in our Milky Way galaxy, and similar numbers in other galaxies. The other is a supermassive black hole that is millions to billions of times the mass of our Sun. It's believed that this humongous monster lives at the center of most every large galaxy. Our own Milky Way galaxy has one. Yet whether they're stellar mass size or supermassive, all black holes are cosmic cannibals.
A black hole, in some sense, is like a cosmic roach motel. Everything checks in, but nothing checks out. A trip to a black hole would be fantastic, almost psychedelic. It's like having a near-death experience. As you get even closer to the black hole, tidal forces begin to stretch your body apart so that the top of your body and the bottom of your body experience different gravitational forces, and you become spaghettified. Eventually, even the atoms of your body become noodles and become ripped apart.
In the case of a supermassive black hole, the process of spaghettification is somewhat different. The person jumping in wouldn't be spaghettified until passing through the event horizon. And the reason for that is because the tidal forces that would stretch him aren't strong enough until you get closer to the singularity. So the person jumping in would have a few moments of perception that they were inside of a black hole, and they could marvel at that idea before they plunged toward the singularity and then became spaghettified.
And if one black hole isn't violent enough, try two black holes dueling for dominance. In the vastness of space, black holes occasionally pair off. It may appear as though they're engaging in some sort of cosmic courtship. But these unions are anything but harmonious. When two black holes get too close, they become trapped by each other's gravity. The two orbit around each other like whirling dervishes. These binary black holes will eventually collide and coalesce.
It's believed that collisions between black holes will be quite common. They would be in orbit around each other and then spiral inwards, and at some point they would coalesce. And that coalescence creates a huge disturbance in space-time.
If you have two objects that are bending space a lot around them, and they merge together, then you'll get this ripple, this wave going out, carrying energy with it.
Typically, when black holes collide, they create wild vibrations called gravitational waves, which spread across the fabric of space and time.
These ripples would be just like the ripples you would have, say, on the surface of a pond. If you threw a pebble into a pond, it creates a disturbance, and then you see the ripples carrying that disturbance away to far points of the pond.
Modern science continues to unravel the mysteries surrounding black holes. But for some, one enduring question remains.
The deepest question in all of black hole physics is what lies on the other side of a black hole? What happens if you throw the encyclopedia into a black hole? Is all that information lost? We don't know for sure.
According to Einstein's general relativity laws, nothing can ever come out of a black hole. But if a black hole is extremely tiny, the laws of quantum mechanics merge with the laws of general relativity. Quantum mechanics governs the world of the very small, such as electrons, neutrons, and other subatomic particles. General relativity rules the world of the very large, where ordinary gravity is dominant, like planets, stars, and galaxies.
The fact is, when you put together quantum theory with black holes, you find that they aren't completely inert objects that only suck things in and nothing comes out. They actually radiate.
The black holes that radiate are called mini black holes, which are much smaller than their stellar mass or supermassive black hole cousins. Celebrated physicist Stephen Hawking proposed that if mini black holes exist, they must emit radiation, which has been named Hawking radiation. It is believed this radiation will cause a tiny black hole to evaporate and potentially disappear. Hawking gave mathematical evidence that when a tiny black hole forms and then evaporates, some of the information that went into the black hole never comes back out. This startling prediction caused a firestorm among physicists because the laws of quantum theory insist that information can never be completely destroyed.
Essentially, the world split into two camps. Those who believed that Hawking's calculation was really it, and the other camp that said, well, Hawking's calculation needs refining. String theory and other theories seem to suggest that the information is actually preserved. It just comes out very subtly.
The question of what happens to the information that goes inside a black hole is, I think, not fully settled. The chemical composition of the objects that went into the black hole and other aspects of them, their color, their temperature, etc., etc. We don't really know what happens to that information.